All right, welcome everyone. Today we're going to talk about object-oriented programming. We're going to talk about the principles of inheritance and polymorphism. And as a little add-on at the very end, we'll also discuss the concept of composition. So we're going to do a slide deck really quick to kind of see everything from a hypothetical side and see it from the above spectrum. Very much getting our toes dipped into the water. And then from there, we're going to actually dive in depth into how it is that we can apply inheritance and polymorphism. So we're going to start off with when and why you should utilize inheritance, child and parent relationships, the super method. We'll talk about instance versus class methods, the multiple inheritance, and actually, I don't believe we're going to be talking about multiple inheritance today. Let me go ahead and check that. Yeah, we are likely not going to be talking about multiple inheritance today. So please know that that is not going to be a topic that we discuss today. And then we'll talk about composition versus inheritance. All right. Now you're going to be tested on these concepts on the assessment, which is being released tomorrow. We do have a review tomorrow as well, but a lot of these fundamentals are going to be extremely or explicitly tested for in tomorrow's assessment. All right. Does anyone have any questions over the material that we'll be covering? Perfect. So why do we want to utilize inheritance? And we're going to use the same example of a phone here. Now, the phone, when it was very first created, and I tried to find the oldest phone that I could possibly find on Google, right? I know that before they used to look like boxes, but this is what I was able to find. All right, we have a telephone here that holds a certain number or a dial of numbers all around for you to actually be able to place someone's indicator, and then you could send a phone call, right? This was attached to phone lines, and there's quite a bit of functionality in here that's able to capture your voice or capture noise. It's able to transfer noise and it's able to output noise. Now, the functionalities of a telephone or of a phone essentially stayed the same, right? We're still capturing, we're transferring, and we're outputting. But our methods for conducting this might have been altered, not necessarily changed, but altered, right? Before we used to utilize landlines. Nowadays, we don't really need that because we rely heavily on the internet. But before, we used to have things like landlines that would run back and forth to actually be able to reach phones, right? Well, as phones started evolving, started coming out cell phones, right? We have the good old Nokia phone here, the indestructible phone. It's still able to capture, transfer, and output information, right? Or output when you're making the phone call. You can see that it still holds your number dial. So although it is pretty much the next step in technology, it has a lot of commonalities between the two, right? And it's still known as a phone. For if I reference a phone and I show you a picture of this, you could likely identify this as a phone. And same thing goes vice versa. You would still identify this as a phone. That is because they are both phones, right? They share a base class that's able to capture, transfer, and output noise. Then came along the flip phone, a couple years after the Nokias, right? Where the flip phone still holds our nice little keypad to be able to make cellular calls. And then finally, we have something like the modern iPhone or the modern phones that are out there where everything is touchscreen. You don't necessarily see the keypad, so the functionality there has changed a little bit as well, right? Because now everything is done through touch. Once you go to make a phone call, so we're practicing abstraction and encapsulation. Once you go to make a phone call, only then does a keyboard become exposed on the screen, right? So this is the concept of inheritance. You take a base class, which holds the functionalities that you want to repeat, and you inherit them. You improve them in the next class. And this avoids one of the two concepts that we've been talking about since we started this class, right? We have the don't repeat yourself class and the single responsibility, or excuse me, the single responsibility principle and the don't repeat yourself. All right. This actually achieves both to an extent. By writing a singular class, I can now inherit it in other classes and I don't have to repeat myself, right? And if I'm following the single responsibility principle, well, now in all of these other instances, if the functions of making a phone call changes, I only have to change it in one class. And all of the classes that inherit from it would inherit those changes. Does anyone have any questions regarding inheritance? Okay, let's go ahead and keep moving forward here. And we're going to wait for this polymorphism portion until part two of our lecture. We're just going to leave it here at inheritance. So here we have our phone. All right, let's actually see a coding example of how we could apply this. And let's start off with some dogs. All right, well, here we have a German Shepherd dog. A German Shepherd dog is able to do all of these things. It has all of these getters and setters. All right, well, I'm actually going to dial this down a little bit. And let's just quickly make a copy of this German Shepherd dog. So first of all, I'm gonna change into my classes directory. If I could figure out where I'm at, apparently. Oh, it's py classes. All right. And then I'm going to rename this file from dogs to gsd.py or gsds.py. From there, I'm going to copy this gsds.py and create a dogs.py. Kind of a repetitive process there. Definitely did not need to go about, there was a better way to do that. All right, so now we have our German Shepherd dog. But in here, I'm actually gonna tackle it down a little bit. Gonna say, hey, I just want this to be a dog. I don't want this thing to be a German Shepherd dog. I want to represent dogs that are alive. And for breed, I'm just gonna set it as none. Whoa, clicked on some buttons there. Did something weird. I'm gonna set it as none. All right, so now I have my breed for a dog. This is a general dog. Maybe I don't know what their breeds are. I know it's going to have a name, age, height, and color. Okay, so all of that can stay the same, right? Its sleeping portion, I don't necessarily care about sleeping, but in order to keep the methods, sure, we'll keep it. And then we have this dogs.alldogs.append, which is happening every single time a dog is initialized. This is fine, right? Maybe I want to keep track of all the different dogs. Now I have my properties here where I have my property of sleep. I have my property of name, all has its getters and setters, fantastic. And then I have a couple of methods. I have go to sleep, I have fetch, bark, etc. All right. So now my dogs class has been created. We made only a couple of changes. And now what we can do is we can take this dog class and essentially inherit from it so that we always have some German Shepherd dogs. Let me actually clean up main.py here. We have a lot of the stuff from a previous lecture. Whoa. So here we have our German Shepherd dogs. And as of now, you can see that this fails, right? Instead of bringing this in from pyclasses.dogs, I want to bring it in from GSDs, right? And then we don't have an issue. Let's make sure this actually still works. I'm gonna run .py, and it looks like my Docker is disconnected. I apologize, everybody. I don't need Docker, to be fair. I could just run Python main.py, and you could see there that I have all of my information there. There's all of my uh, instances being printed out. All right, I have my dogs available to me. Great. Well, so now nothing has changed. But if I put GSDs and I put dogs side by side, I am violating one of our principles big time. And what is that principle that I'm violating? Is it the single responsibility principle? Is it the don't repeat yourself? What am I violating here? Let's hear it, Keith.
Don't repeat yourself. Right.
Yeah, don't repeat yourself. All right. I am writing a complete repetition of this entire dog class. Well, I want this entire dog class to easily be represented in here. And if I'm comparing them, because we just did this inside of our lecture, I know that this is an exact copy of the other class. So maybe there's a better way to represent this German Shepherd dog. All right. I'm going to actually delete everything from the German Shepherd dog, and I'm going to pass. Now, a German Shepherd dog is, in fact, a dog, right? There's not discussion here as to whether I'm trying to represent a dog or not. So what I can do is I can say, hey, from classes, or excuse me, from py classes dot dogs, I want to import the dog class. And now what I want to do is I want to inherit the dog class. I want to adopt all of these initializers. I want to adopt all of its getters and setters and all of its methods. Okay, well, how do I do that? It's actually a lot simpler than one might think. All I need to do is in parentheses to the right of my declaration of my class, I'm going to specify what it is that I'm inheriting from. I am inheriting from the dog class. All right. Well, this brings me to my initializer method, right? Does that mean that I need to write all of this out all over again, right? Would I want the same exact initializer on the right-hand side? Something that looks as such? That was a question for the classroom. I apologize. Probably sounded like a rhetorical question. Let's hear it, Albert.
Your question was, did we need to copy everything from dog class to German Shepherd class?
Yeah, when I'm running this whole initialization process, right? Do I really
Uh,
want to copy this?
I don't think you do because you are importing it from your py classes dot dogs.
Okay,
Your dog class from that.
awesome. So you said importing, and when I think of importing, I'm thinking about this, right? And rather than thinking about importing, I want you all to start thinking about inheriting, right? We inherited the initialization method from our dog class. All right. Well, how do I actually use the init method from the dog class? When I use the init method from the dog class, am I just going to quite literally put pass and then avoid using this dog class? Let's check that out, right? Let's see what happens when we do this. All right, I'm gonna go ahead and run Python main.py. Hey, everything works perfectly fine, right? I can see that all of my dogs are actually being created and nothing is actually being broken. Okay, I'm gonna comment out these representation methods and this string method down here so we can see what's actually being stored inside of our machine. When I execute this, we can see that what we're executing is a German Shepherd dog. Even though we're executing the German Shepherd dog, which is also inheriting from the dog class, there was nothing additional that we needed to pass. So, for example, at this point, if I wanted to have something like, hey, I want there to be Chihuahuas as well. Chihuahua. There you go. Why not? Chihuahua dog. This dog can also inherit from dog. right? And say pass. And that could allow me to go to my main script. And inside of my main script, I could turn socks into a chihuahua, right? I think that makes more sense for a name like socks. Oh, probably want to import chihuahua. And now when we execute this, if we take a look at all dogs holds a German Shepherd, one more German Shepherd, and then it holds a Chihuahua dog. Well, what about this list? This list of all dogs that's being printed out into my terminal. Where is it coming from? And why does it hold a mixture of German Shepherds and Chihuahua dogs? Let's hear it, Kaylee.
Is it because both German Shepherd and Chihuahua are inheriting from dogs, so they both have the information the from the name, age, height, color, etc.?
Yeah, nice. So it's because they're inheriting from all dogs. So they share the same init method. Notice in the init method, we're doing dog dot all dogs dot append. So regardless whether we're creating a German Shepherd dog or if we're creating a Chihuahua dog, we are still adding them. All right, nice. Okay, so now we get the concept of inheritance, of being able to grab one singular class and share all of its attributes and methods to other classes. But this doesn't really seem like a good match, right? As of now, all I'm doing is basically inheriting everything. And I could have easily accomplished something like this by just saying, hey, there's different types of dogs, and I just got to choose one of them. So every time it's initialized, I'm placing, hey, the breed is going to be a German Shepherd, the breed is going to be a Chihuahua dog, etc. Right? So this seems like overkill. All right, well, let's actually take a deeper look at this German Shepherd dog. I'm going to take off this pass, and I'm actually going to bring in the init method. I'm going to go ahead and open this up a little bit just so that we have some more real estate. And this shouldn't be outputting a dog. This should be outputting a German Shepherd dog. All right. So there you go. We have our initializer method. It's taking in all of these things, and we want it to still hold all of the properties and values that are assigned during the dog class. But let's say I have a couple of additional ones, right? A German Shepherd dog is typically a bigger dog, and maybe it's trained, right? Maybe this kind of training is unique to only a German Shepherd dog. So we could have something like, hey, trained. Is that true or false? Has it been trained? Right? Is it also serving as a guard dog? Right? Which could also be true or false. All right. And then does it have its KSA certificate, which can also be a true or false? Right? These three new attributes that we're adding here are going to be unique to only the German Shepherd dog. All right, so let's go ahead and add those, right? Because as of now, we have everything from the dog class. Let's add them so that we have them available to us. We're going to go ahead and say, hey, I now want for self.trained to be equal to trained. I want self.guard to be equal to guard. I want self.ksa to be equal to KSA. And I could probably do all of my getters and setters for these as well, right? Which, because they are all Booleans, I can probably do a little bit of rinse and repeat here. Um, Due to time constraints, we're going to actually skip over the getters and setters portions, but know that ideally you want to create getters and setters for these. All right. Well, now I have three unique attributes that I want to add. But because I have three unique attributes, does that mean that I want to copy all of this all over again? All right, let's actually take a look at our main.py and make sure that it's actually able to execute. All right, so here we have main.py on the left-hand side. We have two German Shepherd dogs that now need some information for them being trained. We're just going to go ahead and do true, true, and true. I'm going to copy those and send them. And all of this should execute perfectly fine, right? I should be able to see, hey, these are German Shepherd dogs. Everything's working great. They're being stored just the way I expected them. And we still have our Chihuahua being stored. But this very much still looks like I'm violating the don't repeat yourself principle, right? And the whole point of this is for me to not have to repeat myself. So if inheritance is telling me, hey, you should be able to apply the dry concept as much as possible, then I'm probably doing this wrong. Okay, so how do I solve this? Well, you would solve this by utilizing something called the super method. This entire dog, dot all hands, self dot name, all of these attributes are attributes that need to be handled by the dog class. Right? So these attributes belong to the dog, which the dog class is the parent class of the German Shepherd dog. The attributes of self.trained, self.guard, and self.ksa, these are unique to the GSD. All right. Well, how do we pass these down to the dog class? Because as of now, if I try to run this, you're going to notice that although it didn't even work, right? Some of these dogs aren't even initialized properly. The only one that still gets passed down is Chihuahua. Okay. Or actually, they didn't fail. They all were created, but we didn't keep a record of them because the dog class or the dog initializer is what appends them into the all dogs. Okay, so how do we fix this, right? How do we make sure this happens? What we do is we can say something like, hey, dog, this is the dog class. I want you to be initialized. And once we initialize the dog class, we could pass in things like name, age, we can pass in the height. We could pass in the color. But you'll notice that right now, it's also not tracking. It's saying, hey, that we have name, string, but it's going to be missing one positional argument. If I try to run this, it's going to tell me, hey, we're missing one positional argument of color. Well, that's because I need to pass in self as well. And now when I run it, everything works great. Right? I am calling the class of dog, and through dot notation, I'm accessing the underscore underscore init method to be able to call self, name, age, height, and color. Right, so that basically turns all of this into redundant code. And that could remove it. There is still a little bit of repetition that's happening between here and here. The way to solve this is going to be to quarks. We're not going to do a dive into quarks today. But know that if you are truly trying to achieve a don't repeat yourself kind of environment and you don't even want to repeat yourself within the initializers, all you need to do is apply quarks. All right. We've covered quite a bit of material here. We have the dog class. The dog class is being inherited by the German Shepherd class. We have some unique attributes to the German Shepherd class, which is trained, guard, and KSA. And then we have some attributes that we are still going to use within the dog class. And we pass those into the dog underscore underscore init method. All right. At this point, does anyone have any questions regarding inheritance? This here, Kaylee.
So the dog dot underscore init underscore, that's like it's like bringing in the initializations from the dog class into the German Shepherd class, so you don't have to rewrite self.name equals name, right?
That's right. Yeah. So we're essentially just grabbing this entire portion here and we're inserting it in line 15.
All right, cool.
Mohammed?
Uh, can a class like German Shepherd Dog have its own class level attribute, or does it only inherit from the main class?
Yeah, it's a great question. It can still have its own class level attributes. It does not have to inherit everything from the main class, right? Um, Maybe we want only German Shepherd dogs to be counted in here, right? We want to maybe keep a record of German Shepherd dogs. So all GSD dogs. And we also turn this into a list. At the end of this, we can say, hey, GSD dogs, or excuse me, this is German Shepherd dog dot all GSD dogs dot append, and we could pass in self, right? In main.py, we can print all dogs straight from the dogs class. Oh, I'm not importing it. Let's do socks. Actually, let's do a polo. And I could also print all GSD dogs. When I run this, I should get two separate print statements, one holding a total of three, right? Here we have a German Shepherd dog. We have two German Shepherd dogs. And then finally, we have the Chihuahua. All right, so there's three dogs in the all dogs. And then for only the German Shepherd dogs, let me use a different color here. Only the German Shepherd dogs, we have 1 and 2. Does that answer your question, Mohammed?
Yes.
All right. Any other questions? All right, so let's finish cleaning this up then. All right, we have our task, or excuse me, we have our German Shepherd dog. Currently, it's utilizing this dog dot underscore underscore init, and I'm passing in self. What I'm about to teach you guys is an alternative to this. It is not a replacement, it is an alternative. And something that's very commonly used in Python conventions now, right? Rather than calling the dog.init method the way we're doing it here, what you could do is you could utilize the super keyword. And by calling super.init, we don't have to pass in self. Fundamentally, they work exactly the same. The super method is ensuring that there's a connection between the German Shepherd dog and the dog class, and it does not pass in self. Right? Super refers to the parental class of dog. If we run this code now, it's going to work exactly the same. That is the super method. Any questions regarding inheritance up to this point? Let's hear it, James.
Uh, Between the two, super and dog dot in it, is there a preference that we should be leaning towards, or it doesn't really matter as long as we use one of them effectively?
Yeah, the preference is going to be the super method. That's kind of the standard convention nowadays when it comes to writing Python OOP.
Gotcha.
All right. Awesome. Doesn't seem like we have any other questions. So because we don't have any other questions, I'm going to ask you all to help me build this Chihuahua class. For this Chihuahua class, I want you all to help me make sure that a Chihuahua could possibly be a purse dog, right? And I want this to be a Boolean. At the same time, I would want you all to help me assert whether this Chihuahua will bite. And again, this will be a Boolean. Awesome. So there's those two unique attributes that I want to add to the Chihuahua dog. And I want to utilize inheritance. I still want it to be able to keep track. And actually, let's do that as well. I want to make sure that we keep track or keep a record of all Chihuahuas created. So how can I accomplish this behavior while still inheriting from the dog class? All right, Kaylee.
I think the first step would be to do either the super initialization or the dog initialization. Uh,
All right, so we
we
do.
would want to transfer over the name, age, height, and color from dogs.
Okay. Got it. So it seems like I'm running into a little bit of an issue right now, right? Because inside of my super method, which is, I think we're going down the right path because we do want to initialize that parental class of dog, right? But first, my Chihuahua probably needs an initializer as well, right? So let's go ahead and wrap that up. Let's go ahead and write our init for a Chihuahua, or init for a Chihuahua can take in self. And we could use the super method to pass in all those attributes. Now notice that they still don't know what name, age, height, and color is. That's because we need to actually write it into our method here. All right, so now we have the name, age, height, and color. What would be next? And let me pass this question off. Let me see. Let me see. Let me hear from Patty. What's next, Patty?
Sorry, just trying to get my, there we go. Just trying to click the audio thing. Okay, so we have that. Sorry, hang on a second. See, we're in it. Sorry, I'm just reading my notes very poorly. Do we want to do right below it, like, because we want to add self dot purse underscore dog? Are we doing? Yeah, we're doing that part, right? Yep.
Okay.
Self dot purse underscore dog. Yep. Okay, and then space equal sign, and then space purse underscore dog again.
All right. So purse dog is equal to purse dog. That I think
Yep.
that makes sense to an extent. But if I hover over purse dog, it's telling me this isn't defined.
Uh, Hang on a sec. Oh, do we have to do above that like a def underscore init underscore? Like, or actually, no, ignore me. My notes are kind of crappy right now. Oh, oh, we didn't make the class. No, you have the class. Sorry. You have the class and it's saying it's not self-doppers. I actually have no idea right now.
Okay. Yeah,
What
no
I'm doing
problem.
wrong.
You're very much going down the right path. So that's good. Awesome. All right, let me pass it on to Simon. Simon, how do I fix this, right? Right now, if I hover over purse dog, it's telling me that this is wrong. But I know this is the behavior that I want to achieve.
Because you're not under the super. You need to put it underneath the super so that it's through the inherited part. Although it's still
Okay.
saying that.
Gotcha. So let's see. The inherited portion is happening here, right? We see that in line 30. So inheritance is checked. We're completed with inheritance. We don't need anything else in regards to applying the inheritance. All
I
right.
see. I misread my notes. Sorry. I see it now.
Oh, then what's
Thank
missing? What's missing? Hit it.
hang on a sec. Super dot init name height age dot. Actually, you know what? Never mind. Ignore me.
All
Never
right.
mind.
Nice.
Sorry. I
Nice
thought I
to
saw
hear.
it, but never mind.
Does it need the arrow with going to dog on the right side of it of the
Yeah,
colon?
yeah, we could do something like, hey, this is actually outputting Chihuahua dog. Okay. Albert, I see you have your hand up.
Just looking at notes and comparing. In your I'm trying to see how to word it. Where in your def init, in your parameters, you need to add more to that. So we want to add purse dog and will bite. Yes, in there.
Nice. So we want to add purse dog. And now you'll notice that it can be recognized. And we want to add will bite. Fantastic. So now we have our last two parameters that we, or excuse me, attributes that we want to add to our Chihuahua dog. So we could follow the same convention, right? We have self dot will bite, and we could also make that equal to will bite. Okay, great. So this takes care of initializing the dog, which is our inheritance portion. Fantastic. We're also taking care of making sure that we have a dog that we can identify whether it's a purse dog or not, and we can identify whether the dog will bite or not. All right, nice. But now we have one more thing left over, which is being able to keep a record. And Dom, do you have a question?
Yeah, I'm sorry. Can you just, I'm confused on the adding in the purse dog and the will bite into that def in it. What's confusing me is that like you have the inherited piece and then you're adding in the new pieces there. It's not clicking. Can you go over that again?
Yeah, absolutely. Let's talk about that. If we open this up and let's take a look at the dog class as well. Okay. So this super dot underscore underscore init. This here is actually calling the init method that we're seeing inside of the dog class. That's what's happening in line 30. But underscore underscore init is a method, right? And a method is essentially just the same thing as a function, but written inside of a class. Well, notice that this method holds parameters, right? It holds the parameter of name, age, height, and color. So that means I can't create a dog unless I'm able to provide name, age, height, and color. My super method is referencing the dog. So in order to be able to create a dog, I need the name, age, height, and color. All right. So I'm taking this into all of these parameters here, and I'm passing them up to be able to create my dog class. But this is a method that's nested inside of another method, right? It's a function that's nested inside of a function. So for example, if I were to remove all of these, well, now my init method would fail. Yes, I do need to pass in name, age, height, and color, but I don't just need text. I need values to be able to pass in there. All right, so I need to make the connection through parameters. When I bring back all of my parameters that are going to be passed in, then all of my code works properly, all right, because I can pass in all of the initialization. When I can cross it out, name is going to my super, age is going to my super, height is going to my super, and color is also going to my super. So all of these attributes here, I don't have to worry about them because my inherited class of dog is going to set all of those values for me. All right. Now the only thing left over are my uniques, which is purse dog and will bite. These are unique to the Chihuahua class. At this point, my inherited class, if I passed them in, it would throw an error and it would say, hey, I have no idea what to do with this. You never once did we talk about anything about a purse dog or will bite. All right. But the Chihuahua class does need to know it. So instead of passing it into the initializer, we come down below and we make new unique attributes that only belong to the Chihuahua class. And that's why they get divided like that. Does that answer your question, Dom?
Yeah, that was exactly what I needed. Thank you. That was way more clear now in my brain. Thank you.
Awesome. Yeah, no problem. All right, let's hear it, James.
Uh, Since we're not specifying the dot sleep in the child, does that mean we're not bringing it over into the child?
That's a great question, right? Dot sleep is not being passed in into any portion of the Chihuahua dog, and it's not being passed in into the initializer. So does that mean that it doesn't exist? Well, let's take a look at the dot class. Dot sleep does not require a value. It is not looking for a parameter from the initialization method, but it is an attribute that is being set to the dog class, right? So to answer your question, even though we're not passing it in, self.sleep does exist within the Chihuahua. And we could see this inside of the main class. If I come over to socks and I just print socks dot sleep and I go to print this out. Oh, my Chihuahua was failing. I'll fix that here shortly. Oh, I know why my Chihuahua was failing is because I passed the purse dogs. Let me quickly fix that. All Chihuahuas are purse dogs and all Chihuahuas will bite. Let's see. You can see that it comes back as false. All right. Socks is a Chihuahua. Never once did I specify anything about sleep. But because I'm inheriting from dog, I still have that attribute. Does that answer your question, James?
Yes. Thank you.
Of course. All right, Simon.
In the gsds.py file, if you scroll up a little bit to the top of it, I just want to see if I see something missing. Oh, yeah, no, I was missing. I thought the def init didn't have a closed parentheses. I was wondering why it was working, but it is closed, so I'm good. Thanks.
Of course, no problem. All right. So now we have our ability to have our purse dog and our will bite. But we're missing one last requirement, which is being able to keep a record of all Chihuahuas created. How do I do that? Let's hear it, Chris.
You would just do it the same way you did it in the dog, um, in the dog thing where you make it and you would make the list inside of the class Chihuahua, not in the initial definition.
Okay, so we have all Chihuahua dogs. Make this into a list as a class attribute.
Mhm.
Nice.
And then you should be able to just you should be able to do Chihuahua dog, Chihuahua dog, dot all Chihuahua dogs, um, and then dot append self.
Awesome. Nice. So now we go to main.py. I'm actually going to bring back these. Oh, nope, I don't want to bring back the representation methods just yet. Let's print all dogs, all GSD dogs, and let's also print socks dot all Chihuahua dogs. As a matter of fact, let's do LENs. Now, when we run this, we can see there's a total of 3 dogs that are created. 1, 2, and 3. There's 2 German Shepherd dogs that are created. 1 and 2. And there is 1 Chihuahua dog, which is in line 8. Chihuahua. All right, awesome. Let's hear it, Albert.
In your init, where it has the parameters, you have to set those parameters to what classes you want them to be.
Could you be a little
So,
bit more specific?
so like in your, let's see, in line 31, in your parameters, name, age, height, color, etc., would you have to set name, colon, the string, age, colon, integer, and so on and so forth?
You don't have to use the same description, right? Remember, these are just essentially suggestions. They don't have a hard reinforcement. Um, but our getters and setters are going to throw a fit if we don't pass the correct values. So ideally, you would want to have some sort of specification here saying like, hey, you probably need to pass in these correct values, right? Otherwise, our getters and setters in our init method are going to fail. Does that answer your question, Albert?
Yes, sir.
All right. Dom?
I'm sorry if this is a dumb question, but why isn't there like a at for the methods like there is for the classes? A decorator. Why isn't there like a decorator for the method? So you could say, oh, this is a method. Just curious.
Oh, got it. Like an instance method
Yeah.
for classes. Why is there not a decorator? I actually don't know. I think whoever designed it probably just made the decision on that and pulled the trigger. I don't know if there's like a deeper meaning behind it. I'll have to look that up. I'm not sure. Kevin, do you know by any chance? He's either silent or away. So yeah, I really don't know. I apologize, Dom.
Sorry, I
That was
wasn't.
a
I
good
had my
question.
headphones up, but I didn't hear you call my name.
Oh, okay. We were asking if by any chance you knew why the it is that class methods, or excuse me, instance methods don't have a decorator.
I think it's just because that's the default, so it didn't need one. That's my understanding.
Yeah, right. The way that I see it is self is essentially like its decorator, but self is a keyword. It's not a decorator. So I get where you're coming from. Why does everything else have decorators, but not this one? Yeah.
I was just the reason why I asked is I was just trying to understand if there was something unique about this property different that was different. But I get it. Self is our um, essential decorator here. That makes sense.
Awesome. All right. Any other questions? Okay, fantastic. If there aren't any other questions, this was inheritance. Again, you inherit a class by wrapping it inside of parentheses next to the class declaration. By doing so, you're going to inherit all attributes and methods, both class and instance, whenever an instance gets created. If there are unique values that you want to add, your unique values could be added utilizing self dot, the same dot notation, right? We even have the unique value for German Shepherd dog there. And when it comes to the attributes that must be passed down to the inherited class, such as dog, you use the super method, the super underscore underscore init method. And you pass in all of the attributes it needs to initialize your inherited class. All right, everyone. I'm going to go ahead and stop our recording here.